Good evening, everyone. Welcome to the British Tunnelling Society's November evening presentation. And welcome also, we have 40 people at the moment online joining us. I expect that number will go up as the evening goes on. So tonight's presentation is on carbon management, specifically on the Copenhagen Metro. It's very much a hot topic and something the industry is trying to get better at. In improving and optimizing our carbon management, carbon reduction. So I'm very pleased we're having this presentation tonight. We have two speakers. And I think, John, you're going to speak first, aren't you? So John Banyai will be the first speaker. Team leader for innovation for Metroselskabet. John is a highly experienced tunneling engineer who has worked on all types of tunnels around the world, ranging from pipe jacks to sprayed concrete lined tunnels, from segmental linings to immersed tubes. He started his career in the UK, working as a consultant before relocating to Copenhagen in Denmark 15 years ago. He has worked on many major projects in the UK and abroad, including Heathrow Terminal 5, Crossrail, Fehmarn Belt Tunnel between Denmark and Germany, and the Marieholm Immersed Tube Tunnel in Sweden. John has supported Copenhagen Metro on projects since 2012 for the M3 City Ringen, the M4 line, and now the future M5 line and the M4 extension. John graduated from UCL in 2001, and he is also the ICE's country representative for Denmark. And the second speaker is Alun Thomas, who is the carbon manager for Metroselskabet. Alun is an accomplished tunnel designer and a recognized specialist in sustainability. He has extensive experience across all forms of tunneling, from segmental linings to immersed tube tunnels, and has contributed to major international projects, including Crossrail, the Hong Kong and Delhi metros, Heathrow Terminal 5, and the Karanjunka hydropower scheme. He is author of a book on sprayed concrete lined tunnels and has published more than 50 articles covering topics ranging from numerical modeling to risk management. He is also a technical expert in sustainability within tunneling, with particular expertise in life cycle analysis, carbon footprint assessments, carbon management, and low carbon materials. He is actively involved in numerous industry bodies, including ITA Working Group 12 for sprayed concrete, which he served as vice animator from 2019 to 2022, the ITA Sustainability Group, the ITA Tech Group on low carbon concrete linings, and previously chaired the ITA Tech Activity Group for precast fiber reinforced concrete segments. If that isn't enough, Alun is also an active member of Engineers Without Borders in Denmark. Okay, so John, can I ask you to give your presentation, please?
Good evening, everybody. I can got the lights in my eyes a little bit. It's a pleasure to be here. I was reminded yesterday that the last time I was up here was 16 years ago, and it's really nice to be back here. It's a pleasure. 16 years ago, I had the honour of being part of I think they call it the Christmas debate, where I was here with. They matched some young members up with some of the more of the grandfathers of tunnelling. So I was matched with Harnick Mann. I was with then they had Neville Harrison and John Edwards, and we had this debate about is the BTS doing enough for the next generation of the young members. I do the short straw, and I had to defend the argument that the BTS was not doing enough for the young members. 16 years later, it's not lost on me that I'm a bit older now, but it's actually really nice to go and see that the BTS has done a really good job. And it's really nice to see lots of young members here tonight. So thank you for proving me wrong. So I'm going to talk you through a little bit about who are Metroselskabet and what are we doing. I'm the innovation lead for Copenhagen Metro, so I'll be dropping in a little bit about what I do before handing over to Alun, who will talk you through what we do for carbon management. So the Copenhagen Metro. Some of you may have been to Copenhagen and used the Metro, but for those that haven't, I thought I'd give a bit of an introduction. So Copenhagen Metro, we have 4 lines at the moment. We are owned by 3 different parties. 50% by Copenhagen City, 7.2% by Frederiksberg, which is like an enclave within Copenhagen, and then the rest of it, which is 41.7%, is owned by the state. That's the Ministry of Transport, if you like. We have a board that we report to, and the board report to those 3 owners. So that's quite important about the way we make our decisions, what we do and who we do it for. So effectively, we report to the Mayor of Copenhagen and the Mayor of Frederiksberg and the Minister of Transport. The main task that we have is to operate the metro and to look at new lines, new generation. I've added an extra slide at the very last minute, which is this one here. This week, in fact, on Monday, the chairman of our board of directors was interviewed, and I thought I'd add this because it's quite a powerful statement. He said that we've got to start taking some more risks. If we want to go and solve the climate crisis, we've got to do something a little bit different. So he's led the way and said, on the front pages of the newspapers, we've got to do something here. We've got to solve the climate change, the carbon, biodiversity, and he's gone out there and said we might need to be a little less risk averse, it's almost like a mandate to do some stuff a little bit different, which is great. So here's a map of Copenhagen with our lines in it, the colourful one. So you've got the red, yellow, green, and blue. I'll tell you through a little bit of a brief history of the Metro of Copenhagen, because we're a fairly young metro. So the first metro was opened in 2002. It basically linked the city of Copenhagen to the control and maintenance depot, which is where our offices are. So that was 2002. So that's only 23 years ago. So nothing is older than that on the metro, including the trains. So they're beginning to get a bit tired. A few years later, in 2007, we extended the metro down to the airport, which was a game changer. For things like tourism, it allowed people to be 16 minutes away from the airport to the city centre. And that's been very noticeable about the way that people use Denmark as a bit of a hub for businesses and such. Already by 2007, we were planning the next metro. So the M3 line, which opened in 2019, was in preparation from about 2008 up until opening in 2019. The city ring and effectively linked up all the boroughs around Copenhagen with 2 interchanges with the existing M1 and M2. In parallel to that, there was an extension that was a spur off to the north that opened in 2020, which we call the M4. And then to the south, we opened up that in 2024, the southern spur, down to what we call the South Harbour, Sydhavn. Where are we today? We are already planning for the M4 extension, which I won't bore you with because it's not a tunnel, it's elevated section, so that's not interesting to you guys. And then I'll introduce a little bit about the M5, which we are busy in the planning phase for now. That will open up in 2036 for phase 1, and all things being well, 2045 for phase 2. By then, I sincerely hope to have retired. I'm also going to touch upon the fact that we do plan for the future, and you can see there in the bottom right-hand corner, we are looking at a whole bunch of lines that might open up beyond that up until 2070. What does Copenhagen look like in 2070? Which is at very least interesting in terms of the way that the city may change, but it's actually not at the back of our mind, it's quite in the middle of our mind, if not at the front. So what do we do at the Copenhagen Metro? The Metro, there's some numbers here that you can read. I'm not going to read all of them because I think sometimes it's just nice to go and stare at a screen while I just rap over the top. Last year we had 126 million passengers. That's roughly about 10 million a month. I have to say that last month we actually broke our own world record, our world record for Copenhagen. Last month in October we had 12 million. That was largely due to the fact that Ed Sheeran did a four-day concert on the Metro. We actually, just to boost my numbers even further, we got him to do the station announcement for 4 days, which was great. We just had our people call his people, and he actually came in and did the station announcement about when the closing doors and stuff. A couple of numbers there that are really interesting is the fact that the customer satisfaction is 98%. That's pretty good. Yet we've still got a little bit way to go, I'm told. We've got to keep on pushing that. 99% next year would be great, and if we can get 100%, that'd be fantastic as well. And operation stability of 99% is remarkable. That's maybe possible because the way that we set up the metro in the first place. We've got driverless transportation, and we run 24/7. Now, that's really 24/7 because we've got enough crossovers that even at night we can do maintenance while operating every 20 minutes. So that's true 24/7 running. It can be a bit hellish, but it does work. So I think we're all quite proud of the fact that we can maintain those satisfaction levels, that stability levels, and run it around the clock. A few other things that we do, just to let you know a little bit more about Metroselskabet. We've also got a light rail system, which I'm going to brush over because it's not in a tunnel. But we've also been working on this for years now. It opened last month to great success. We opened up the bottom 14 stations, which seems to be working so far so good. But that was only about 3 weeks ago. So yeah, so far so good. And we'll open up the next 15 stations in I think it's summer next year. Another string to our bow is that we also get very highly involved in the urban development of Copenhagen. So we have our team of urban planners that work together with the way that we shape the city. So particularly in Copenhagen Syd, which is Copenhagen South, which is the bit where I've circled red there, there will be an urban development over the top of some of our train lines, including like a 100-meter high it's 100-meter skyscraper, but some fairly significant buildings on top, because we realised that the metro brings about developments, and we thought, why not be a part of that? So we're leading from the front with the urban development of Copenhagen. So, M5. There's a statement that was made about the M5 a few years ago. The carbon footprint of the construction of new metro projects must be halved compared to the current metro, while all other climate footprints are minimised. That's quite a bold statement, and maybe this is perhaps why I joined the metro, because it was such an evocative statement about what our intent was, that it was difficult to sort of look away from it. I think that this is an incredibly powerful thing, and we've got the mandate from our chairman of the board to go and do something a little bit different. The way they're doing this is through through innovation. I mean, my role, I've only been at Metro for about 18 months, but before that, the innovation team has been going on with a program of innovation studies for about 5 years. That's fantastic, because that's actually given us time to go and do things. So before I joined the Metro, I was doing some of those studies, and then when I joined, I was leading those studies to do even more studies about what could we do to make things better. Innovation it's a funny thing. It's not that I just sit in a little black box in the corner thinking up good ideas, because that is absolutely not what I do. But I do host the fact that in the environment we sit in, a new idea is welcome to be discussed. It's a safe place to go and have a good idea. We have a little team that write these things down. We screen them, we evaluate them, we organise budget for funding for studies, and eventually we might get some of those innovations to work. I've got to be clear about what an innovation is, because people think that I might be doing something we might be doing something a bit crazy. We're not talking about, strapping lightsabers to fronts of TBMs. We're not doing the wild stuff. We're typically doing things that have been tried elsewhere in the world, but we haven't done them in Copenhagen. So our version of innovation might be different to your version of innovation, but for us, it is innovation, because we've got to convince our stakeholders, our clients, our owners that this is going to work. So what lands on my desk as an innovation, often by the time we've actually said yes to it, it isn't an innovation, because it's been done before somewhere around the world. But it does take some time to do that, because it's very easy to have an idea that someone gives you and you say, that sounds okay, but you know what? No, we're not going to do it. With a little bit of time, you can say, maybe we can do it, but maybe not. But with a lot of time, you can actually do some research, you can do some studying, you can think about it, work out those risks, work out those problems and solve them. So ultimately you can say maybe yes, that we can do these things. To give you a feel for where we are, in the last 5 years, we have had, for civil works, we've had about 75 innovation ideas, of which 23 of them will be baked into the contract tender when it comes out. For the transportation system, there are over 100. And we know, I think today there's at least 20 of those that are in. Overall, that's about 25% success rate with the ideas. You might say, well, that's 75% of them are bad ideas. They're not, because I think a lot of them are on the cards that we say, well, we're not ruling them out, and we'll actually give them to our contractors and our consultants when the time is right to say, maybe you guys are smarter than us. Don't forget about this. Have a look at it and see what you think. So my role is actually just about M5. It's about the other projects that we've got, which is the M4 extension to the north. It's also, we've got the Triple R project, which is the rolling stock replacement and resignaling. And we've also got some side studies that we support the comuna with. So I was going to talk to you about some of the future metros, but I'm going to go very quickly over it so I don't run out of time, because I will be the one that overruns and it won't be Alan. So Alan, if I do, I'm really sorry. But we do look into the long distant future, which hopefully is long after I've retired, about what happens next. Because when we were developing the M5, the Metro 5 project, the community said, well, but is this the right alignment to choose? Or should we be looking at another alignment? And we said, well, tell you what, we'll look at that, but we'll also look at a bunch of other ones. So you can see the sort of spaghetti diagram here, which got about 27 lines on it, but it shows the intent of where we could go and where we may not go, and where do we go next, and where do we go after that. So we've actually been developing some of the lines a bit more. So you can see that we went now from 27 down to 16, and now we've got 8 sort of favourites. And those 8 have come about because you look at where the people are. So you've got some red, blue, and yellow dots there, which are residential, workplaces, and students. And you can see that there's some gaps there. I've got the older sort of, it's not a very good analogy, the analogy of survivorship bias, where you've got an aeroplane, that you may have seen this, the planes that landed, the ones that didn't get shot down, didn't seem to have bullet holes where the engines were. We are not looking to go and reinforce the bits that are working. We're looking at reinforcing the bits where the gaps are, because we know that if you start to develop a metro, people will go there. So that's the next slide should show where the new lines are, and you can almost see it was filling those gaps. So I'll just go back one. It fills the gaps to the south, to the west, and to the northeast. So we'll be looking to put metros where there are no metros, but where there might not be people, but we know that they will go there. This is a photo of, actually, this is the Metroselskabet offices are just down there to the right. So that's where Alan and I work from a day-to-day basis. This is where the control and maintenance centre is, and it's the southern end of the M1. That's 2002, so that's in sort of living memory for at least me. But today, that's what it looks like. So we build a metro, and all of a sudden, things appear. So in there, you've got residential, you've got some businesses, you've got a sports arena, and that's in the case of 22 years, things have happened. This isn't new. I think the same happened at Canary Wharf, and the same happens, I was going to say Croydon, but maybe not, well, maybe Croydon. The Manhattan of the South. Now, going back to those alignments, we've got a pretty cool tool to do this. We've actually got a GIS database with, GIS, I'm not going to explain what that is, but we've built a tool. I say we've built a Covey built a tool for us, but it allows us to, in real time, draw an alignment and work out what the alignment does. So it's a bit, I'm using Duplo as an analogy because we're Danish, So we've got these building blocks that we can therefore build an alignment on a map in real time. And because it's in GIS, it can bring in loads of data to tell us if this alignment's any good. So the old way to do it was almost you get a map and your alignment, you send it off to somebody to do some analysis. But we can do it in real time. So is this going to, am I going to have to click through it? So we can draw a map, we can draw on the map where alignment is using some building blocks of a straight bit and a curved bit and a vertical curve. We can do that quite quickly, actually. And with that, we instantly get some data that's really useful. So we can go and adjust those alignments, but it will tell us some really interesting facts. I won't go through the data because it's a bit boring, but it's not just passenger numbers. It's about interchange numbers. It's also about how many people will get in from other parts of the city, and the construction cost and the carbon impact. And what's great about it is you can go and change it really quickly. If someone said, get rid of that station, you delete it, put a straight bit in between, and it gives you an updated number instantly. It's super powerful, this forward planning. I know we're not looking at building these till 2070, but in terms of helping to plan the city and what happens next, this is great. And the comuna, the municipality, they love this stuff because they can really think about what do they do next? Where do they invest? Where do they build a new hospital? Do they build a new school here? Because they can see what could happen and also what can't happen, because there are some blockers, you know how that goes. So back to M5. I'm going to just refresh about doing things a bit differently. That's what innovation is all about. But I'll just go back to M1 and M2. This is a sketch from a cafe in Paris that was drawn in 1995. And this was what the guys that thought, let's go and build a metro in Copenhagen, this is what they drew. So you can see the basic format of it is, we build a big watertight box, we put some skylights in the roof and escalators to get in and out. That's our metro, we'll do that everywhere. And we did, and by and large, the sketch from 95 kind of turned into what the Metro became. So I'm not going to say that every single Metro station on M1 and M2 is the same, but it kind of is the same. It's the standard format of a box with some trains at the bottom, 2 escalators get up. So that's the kind of thing. Now, when we looked at M3, and I think it's almost a direct quote from the tender documents, we want more of the same, please. And it was by and large more of the same because we liked it. We liked our Metro. The one main difference is that M1 and M2 has got this grey architecture and M3 has got some colours. It's a bit more than that because when you break it down, while most of them are that big concrete box with some coloured architecture, there's a bit more. So we've actually sort of developed the station methodology. This is quite interesting because for M1 and M2, we had like 3 different types. For M3, we expanded that to having something's a bit deeper, something's a bit shallow, something's a bit elevated. It's a bit more varied. This is really useful because our Metro planner, the GIS tool, it was only so good because it had some standard blocks. And now we've got some new building blocks, which is great because that allows us to go and do the carbon costs and the carbon and the financial costs instantly because we've got some, a new train set to play with. Now, M5 is different again. So you can see there that our stations are all even further different. So again, our sort of building blocks don't work anymore because all 5 of those underground stations are totally different from one another. That's good because if you're standardizing stations, you can guarantee that only one of them is optimal. And now we've got 5 stations, all unique, all optimal. So you can, I'll come back to some of the stations in more detail, but it means that we're going away from modularization and into something a bit more bespoke. I'm going to be brave and try to run a video. Is this going to work? I don't know if this will work. This is our GIS database where we have all of our data stored. This is a fly through of me clicking on a few buttons. So here you can see the alignment with some boreholes, and then clicking through to go and put the contaminated land on it, and then I show where the top of the limestone is. So you can very quickly, as a client, this is great, you can go and see the information you want, and there's loads of information here to go and play with. So you can see there, you've got the top of limestone, you've got your contaminated land, for example, and you can see what your tunnel's going to go through. And I don't know if all of you are doing this, so I thought I'd show you in case you're not. But as a client, this is fab, and there's loads more stuff to go and look through. This next one is looking at the damage assessment. So this is our contours. So all in one place, we can go and zoom in and see what those settlement contours looking like, which buildings are affected, and we can see what we can do about it. So it's all in one place. And there's other things, tabs that you can click on, access to our drawings, access to the EIA. It's great. This is the bit I'm a bit nervous about. So I thought, well, let's do this. You can actually go and do a flyby. So I thought I'll go and do a flyby and talk you through the route. This did not render very well on my laptop, I'm afraid. But some of it did, and then some of it didn't, and then it did again and didn't again. So this is a zoom in on our central station. So just give it a second. So this is Central Station, which is at the very west corner of our alignment. You can see the famous Tivoli Gardens just north of that in the background. And it gives you the option to go and do a flyby in a hot air balloon. I mean, we could have done it in a F-35 or something, but it gives you a hot air balloon. So this is going to just go along the alignment, and it starts off at Central Station. I thought I'm going to run out of time, so I'm going to speed it up a little bit. So you can see some of the challenges that we're crossing here. So we've got the station just next to Central Station, and then it crosses over something like 16 lines of railway, which will be horrible because of settlement, and we're quite shallow. It goes under a conference centre and then over the channel, so we have to go quite deep here. And then it swings around. The turning circle on a hot air balloon is not very good, so it goes off centre there. Then we've got a station there near the beach, and then we go over the park where there's a shaft for ventilation, over towards Danish Radio City, where we've got another station and interchange there with the M1. Then we lose rendering, so it's a bit slow. But then we cut across basically the houses of southern Copenhagen down in Amager, and over to another station there. And then we turn north and head up towards, oh, it's gone really slow, hasn't it? Under more residential properties, over to Legros Parken, which is on the airport branch of the existing metro. So that's a quite interesting interchange station because we expect there to be lots of people using it to get to the airport and to the city. And then it swings around up towards this industrial part of Copenhagen near the beach. And then you can almost see, if it spins around, you can kind of see sort of the look over towards Christianshavn and the Marble Church. Now at this point, we're on an elevated section. This isn't tunneling anymore. This is the future. This is 2045. We're on an elevated section up past the Copenhagen ski slope and power station. So it'll be elevated across here, over towards the harbour, and you can kind of see in the distance to the, oh no, not there, hang on a minute, over the hub, you'll see in the distance Luneta Hub, which is a man-made island, which is basically where we're going to put all the soil from our tunnel. But not all of it. The stuff that's good, we will try to reuse as much as we can for recycled aggregates and backfill, because there's loads of really good stuff, and we just don't have enough gravel and sand in Denmark. Okay, I'm going to rattle on because I'm probably running a bit late, aren't I? We've got some we do have a deep station. So this is one of the deeper stations, which is a bit bigger than our current stations. There are 3 escalators there. It's deep to get under the river. We also have been pushing bicycle parking. If you've been to Denmark, you know that people quite like riding bikes. So where possible, and certainly where we've got 2 boxes put together, there's an opportunity to go and use that space in between to park our bikes in. So here's a good example where we've actually taken full advantage of that sector between the 2 station boxes to have a spiral ramp and cycle parking underground, which is fantastic. That got approved about 3 weeks ago, so everyone that's been working on that has been delighted, because it is an expense, but it's also something that's quite valuable to the customers, if you like. I couldn't really come up and present if I didn't mention the M5 tender that is coming soon. So these are not my slides, these are slides from the procurement team. So this is as much as I can tell you about it, but I thought I'd tell you something. So phase 1, which is the bit in the red box, that will be going to tender next year. So we've got 5 underground stations with 1 elevator station, 6.5 kilometres of twin tube and a short section of viaduct, as well as a control and maintenance centre. Phase 2, don't worry about, that's too far in the future. The way the contract will split is, I can't guarantee it's going to be like this, but it's going to be roughly like this. So we have the transportation system contract, which includes the trains, the vehicles, the maintenance, and the control and maintenance centre. That's the TS contract. And then the civil works include the tunnels, architecture, the M&E, and the permanent way, and the rest of the civil works for stations. The advanced works will come separately. The station areas up at surface level probably come separately, and there may be some other contracts. But I guess that you're going to be most interested in the civil works. That's why I'm mentioning them. BTS lecture wouldn't be the same without a good old-fashioned geological long section. So you can see here green is limestone, and you can also see that we've tried to make those stations as shallow as possible. I'm dreading this because this is where the questions come, because every single station we're coming out of limestone into the bad ground. Sorry, the more challenging ground. But we've done that because we save loads of money, and Alan will tell you we save loads of carbon as well. So that doesn't mean it's sustainability without having a cost impact, which is great. But we do have a bit of mixed face there. So it's unavoidable because all those stations, you've got to go through some of the mixed ground anyway. So if you've got to do a little bit, why not do a lot? He says bravely. The contract will be a design and build for the civil works, ABT 18, for those that know what that is, the Danes in the room. It will be a negotiated procedure. The TS contract, by the way, is going to be competitive dialogue, but we're going to negotiate a procedure for the civil works. We expect maybe 4 pre-qualified. I mean, that's enough for us to handle. And just to let you know, we are going 50%, 50-50 on pricing quality. That's about as much as we can say, other than that we will be paying people that do offer compliant bids. One more slide before I hand over to Alan, and that's on the programme. I had to add this in the last minute there. Last week, we got the EIA approval. That's fantastic news for us. So there was some champagne flying, because getting the EIA approval means we can crack on with the next parts of it. So that happened last week. The next big deadline is getting the Construction Act, which we're expecting to happen in Q2. And kind of when that happens, then we go to tender. So it's targeted that we get it sort of April, May. And as soon as we do that, the documents will be ready and we'll be issuing those tender documents. So at that point, we'll be issuing the tender, the pre-qual at the same time. And then shortly after that, we hope to be going for the full tender later in the year. Advanced works will be happening at the same time, but we think tender award is likely end of 26. And you don't need to care about the TS bit, I guess. So that's all from me. I'm now going to hand over to Alan, who will tell you a bit more of the nitty-gritty about about how we manage the carbon. Thank you, Alan.
Thanks, John. Maybe I'll leave those alone. So yeah, I'm going to go into a bit more detail on the carbon management now. I am aware that I've just flown here to tell you about reducing carbon. So that's, I can't really defend that in great detail. But for those of you who know me, you will recognize that I'm still wearing the same fleece that I bought 25 years ago. So I tried to compensate in other ways. Some of you may be familiar with carbon management, some are less familiar, so I'll start with some of the basic terminology. What is a carbon footprint? It's described as the total of the greenhouse gas emissions related to doing something, creating something, an activity like that. Greenhouse gases, there's carbon dioxide, there's methane, nitrous oxide, various other gases. But to simplify things, we tend to mash that together and talk about a carbon dioxide equivalent, hence the term carbon footprint. On the graphic, you can see national emissions. For all the countries, then normalized by their population. Denmark appears in the green section there of Europe. So on that level, it looks small. If you compare, let's say, to the Middle East, the red spots, if you compare it to Africa, the heel, the purple, huge populations, very small footprints, but nevertheless experiencing the effects of climate change. UK is similar in many respects in terms of carbon footprints to Denmark. If we think about how does that national emission break down into different things, the clothing industry, interestingly, accounts for about 8% of total emissions. So saving your fleece does actually help a little bit. Construction is only about a similar amount. In a westernized country, it's typically about 8% in terms of direct emissions. You can debate indirect, but let's talk mainly about direct emissions. Turning to the metro itself, how does it look? How does it break down? Well, obviously we've got to run the trains. So the little red slice there, that's the energy and the carbon footprint associated with running all the trains, having the lights on in the stations, the escalators, etc. And we have a very green mix in Denmark, so it's quite small, that component. We also obviously have to change those escalators at some point, change the trains. That's the renewals, the light grey section. But most of the footprint actually comes from the physical infrastructure that we put in place. And this would be a typical example. If you looked at, let's say, HS2, you'd see a similar picture, a bit heavier on the train operations because the energy mix is different, but it's a similar picture for mass transit. If you take that construction component and look at how that breaks down, 80% of that comes from the materials. Within that, of course, it's anything related to cement and the steel. Those are the big culprits. The remainder is moving those materials to the construction site and actually putting them in place. As John said, within our business strategy, we have this goal for new lines to cut the footprint of the physical infrastructure in half, which is a pretty dramatic change from what we're doing. That's a relative change, so I should define what the baseline is for that. So the baseline is the as-built design of what we've just opened, which John's just been showing, for example, the City Ring extension to Sydhavn. Imagine building with that design and using current emission factors, that is our baseline. So I like to think that's quite robust and quite sort of close. You can see if you have a baseline that's far away from your start, from where you are today, it can be difficult to have realistic assessments. If we look at the sort of environment we're in, that's also quite similar to what you see. TfL, for example, is looking to cut emissions by 45% from 2022 to 2030. John mentioned that we're owned by the city of Copenhagen. They have a goal to look at the total emissions of citizens and reduce that by 50% in a period from 2019 to 35. So these are pretty common, deep cuts, deep changes in what we're doing to address the issue that we have. Another way of looking at it is the emissions when you normalize them per passenger kilometer. So a fair question is, why are you building anything more, given that there's so much carbon involved in the actual physical infrastructure? Well, we're doing it to deliver low carbon forms of mass transport. The little red slice you see there, that's the same as on the previous slides, that's moving the vehicle. So if you compare a metro train, which is the bottom slide, I'm not sure if I've translated these, so apologies, they're in Danish. The top one is an electric car. So why don't we just all drive electric cars? Well, the reason is when you look at the whole lifespan, so the carbon embodied in the car itself, the battery, that's the blue part, maintaining the roads and renewing the roads, the green part, when you wrap that all up together, that's about 100 grams per passenger kilometre. When you hop on the metro, it's something around 30 grams, so you're 3 times better. So we need to invest some carbon to have a lower form of carbon transport in the future. And we try and work with this all the way through the different stages of the project. Starting at the very beginning, we've talked about the planning stage. At that point, it's all about improvement. How do we build less? How do we build things better? We're shifting, particularly in, let's say, the M5 projects, now into a requiring stage. What do we turn that into in terms of contract documents? How does that translate into what some of you might even see in terms of the tender documents? That's all great. That's all paper. The real test comes when we actually start to build something. First step, of course, will be to monitor the carbon footprint, because we need to know how it's progressing. In the same way you monitor cost, you want to understand, are we heading in the right direction or are we overspending? And we also need to find mechanisms that will reward and inspire people to do more than what we've shown in the reference design in that stage. And that's the sort of loop that we're running through, and we're trying to be, I would say, active in that carbon management as we go along. Anyone who's familiar with sort of change has seen this type of diagram before. Things you do at the beginning have a much bigger impact for less effort. So act early. All very simple. The things you do at that early stage, when you're drawing lines on a map, you're sketching outlines, you're in that beautiful position where you can be saving money as well as saving carbon. So where possible, act early. To inform that, of course, we need to be tracking what the carbon footprint is, and that's why we have this tool, the carbon tool that John mentioned. So from those very early stages, we're setting a baseline. We're trying to understand what the different options look like. As we shift into the more detailed design, it turns into a big spreadsheet. So nothing particularly clever. It's just a big spreadsheet with a lot of numbers, what we call a carbon estimate. And throughout that process, we are trying to lean on the information that we have anyway in the BIM models. Even at this, let's say, an environmental impact assessment stage, we can take these generic Duplo elements that John mentioned and adjust them based on the actual size that we have in this sort of coarse BIM model for the scheme. This tool covers what's called phases A and B in life cycle analysis. So what that means is phase A is extracting materials, processing them, transporting them to site, actually putting them in place. Construction, everything to do with construction. That's phase A. Phase B is the operational phase, which I mentioned before. We don't actually look at the end of life stage because we're talking about 100-year design life. So what happens in 100 years? I have no real idea. And usually it's sort of seen as something positive. You can extract materials, you can reuse them. So rather than give ourselves credit for something we don't actually know how it'll happen, we've just restricted ourselves to phases A and B. And as John said, the ability to draw a line on the map and after a few clicks, you've got some information is fantastic. That carbon assessment covers all the disciplines, all the civil works, the M&E, the architectural finishes. As I said, we're looking at those A and B phases. We try to use as up-to-date emissions factors from generally generic EPDs, the information we have from all the structures. Each of these sort of elements, they're based on data we've pulled out from the existing system. So there's quite a bit behind it. That said, there will be things that we don't have in the model, things that we're missing. So when we communicate externally, we tend to add on a sort of contingency factor to explain that there is uncertainty. This is not a precise science. And so the estimate is a sort of a range at that point. But once we've done that, we end up with this. Lots and lots of lovely numbers. And as engineers, that's exactly what we want, numbers. We have numbers to play with. We've got a huge amount that we can dive into, we can start to interrogate, and that is the raw material that we really love to have to be able to start making informed decisions. You don't really have to worry about the content too much of these slides, but this is the sort of thing we can then communicate to the public. This is from the environmental impact assessment for the M5. So you can see on the left, we can see lots of different options of lines and how do these colored bars break down between the different phases of construction operation. So you can start to make choices about which alignment you might prefer. And on the right-hand side, you can see within an alignment, where are the hotspots? What are the big things? Nice big green slice there belonging to tunnels. You've got different types of stations, and you can start to drill down into that. So that's at that stage. Moving into the design, our consultants have created a really sweet dashboard. And this is open to everybody. It's basically live. It's updated according to the BIM models, the design on a weekly basis, and anyone can look into it. So on the right-hand side, this square, that's the full footprint, all the different blocks, different elements adding up to the total. And if you're curious and you're working on something, you just click on it. So part of the tunnels, I've clicked on there, this blue box. And on the far right, I can now see what is building up to that blue box. And as it happened when I clicked on this, the annulus grout was the biggest item in that section of tunnel, which was quite a surprise. Not the lining, but the annulus grout. And you start to get curious. Well, what is driving that? Why have we specified it in this way that's created that? And that sort of curiosity is exactly what we want to embed this into the normal engineering work, because we as the engineers are the people who can change this. This brings me to a small but really significant point. So on the left-hand side, you see basically a sort of a typical breakdown for stations within a station, the civil works, and within that, the slabs and the floors and so on. That work breakdown structure is exactly the same in the cost estimate and the carbon estimate. So in any item, when we talk about this room, the cost guy has said, well, I'm including the fancy lights and the chairs and the walls and the roof, and the carbon estimate, we have exactly the same things. And when we change something, we want to add fancy lights to the white walls, we can see straight away the cost impact and the carbon impact of that choice. That gives us much more informed decision-making and transparency, which is really, really helpful. The process we run through as you go through that carbon management follows a hierarchy. Don't build things, build less of them, then build something greener. So eliminate, reduce, substitute. That's quite a familiar hierarchy. If you think about safety, what do? We try and eliminate hazards, we mitigate them, and then we start to think about protection. So the ways of thinking are actually very similar to what we're used to as engineers in our daily work. We look for hotspots. We look at the big stuff first, not the little stuff. We apply this sort of hierarchy, and we go through in that sort of logical way through each of these elements, and we run through it again and again, and pull in the innovations that John has produced from his team and put that together. I can never quite remember who said the definition of insanity is doing the same thing repeatedly and expecting a different outcome. But you need to have innovation. We can't just do what we did last year and expect it will be lower carbon. It just simply won't happen. And that's why what John's done with his team, that sprint that they've had to look at all these sort of, 170 items and sift them and develop them and so on, has been so important to feed the work that we're then done for the rest of the engineering. So what I'll try and do now is give you some examples from each of those, from the sort of the don't build, the build less, the build greener, to give you some practical examples of what is going to appear in our reference design and what we've done to try and reduce carbon. First of all, the shallow alignment, which John mentioned, that's a good example of not building. You don't have to have as deep foundations or the deep retaining walls. You're typically shaving 5 to 15% off a box, station box, depending on which type of station it is that you're looking at. Another good example, which comes back to something quite simple, is the fire life. Well, it's not quite simple. It's the fire life safety strategy. So there's quite a bit of complex engineering in that. But that has been developed over years to try and make sure that we do not stop trains in between stations. Various measures are incorporated in that. And we've progressively enhanced that so that the fire brigade has allowed us to remove some of these intermediate shafts. So that straight away, we're saving money because we're not building something, but we're also saving carbon. This is one of my favorites. It is a super nerdy example, the distance from platform to switch. Somewhere, a railway engineer has written down in our specification, it must be 29 meters of straight track for the train running at full speed to be settled before, these are driverless trains obviously, before you go into a switch. We've actually merged the crossovers with the station boxes. That's all together. That train is never going at full speed when it leaves the station because it's accelerating. So we've gone back to them and said, oh, hey guys, think about the actual speed this train is traveling at. What do you actually need in that terms of that distance before you hit the switch? And they thought long and hard about it, and they reduced it, I think, by 13 meters. So it's now only 16 meters. The station box is something about the width of this room, would you say? And the depth. So you think of this sort of volume, we've now taken this volume and removed 16 meters of that. The excavated volume has shrunk, the quantities of concrete and the walls that we've removed have shrunk. So you're saving 6% on the total box there. Again, a good example of not building something. I would love to give you a nice example from the tunnels. Tunnels are not terribly photogenic. It's quite hard to sort of illustrate what things we've changed. So I'll give you an example from the elevated section to again emphasize the point about building less. On the first, the M1, M2 that John mentioned, if you stand on the platform, you can look down the track, and there's a straight line to the next station. Typically, you've got 2 tracks on 2 viaducts, nice sort of architectural view as you go along. One option to achieve a 50% saving is to just delete one of those viaducts. So I've ticked the carbon saving box. Operationally, it's not brilliant. But that's the scale that we're looking at. It's a 50% saving. That is what we are trying to achieve. So we gave that puzzle to the designers and said, we still got to have 2 tracks going between the stations. We've got to keep that operational aspect. What can you produce? And they came up with this very elegant design. So they've put the 2 tracks onto 1 viaduct. We're saving, we're immediately halved the number of piers and the number of foundations that we have. They've actually extended the span. And this very slim deck, which is basically a beam flipped upside down. You can see this sort of, I'm not sure if this pointer will work, but if I understand the structure, like that's the top flange and that's the bottom flange. That's how the beam is working as you go along. And that has saved more than 50% in carbon terms when you combine that with also improvements in the concrete that we're going to use in that structure. So that to me is excellent engineering. So there's no sort of great magic in this in terms of carbon management. This is just really, really good engineering. So finally, we come to the topic of build greener, and this is the one that tends to get a lot of attention. There's endless posts in LinkedIn about miracle materials that will save us all sometime in the future. But please remember, that is the last step in the hierarchy. So once you've reduced the size of everything and reduced what you're building, now we can talk about having lower carbon materials. And of course, we look at the key culprits, anything with cement in it, whether it's grout, or the concrete itself. We can look at lower carbon versions of that. Low carbon steel. As John has sort of already alluded to, a lot of what we've sort of settled on for the moment in our reference design is not really very innovative. We are opening up the spec to have fiber reinforced polymer sleepers at the depot, where we've got lots of switches. There's a particular reason why that could be a good option. That's perhaps one of the few genuinely innovative things. Using steel fibers or any type of fiber in the segments, that's to me not very engineering. That's best practice. But that's just partly the way the process goes. There may be more innovative things coming later down the line. And we also have to look at the actual equipment they're using, because there's that sort of 20% of the construction phase that comes back largely to the actual construction process. There are lots of exciting things happening with concrete, but I think, again, as a general comment, we really need to go back to the basic questions about what are we trying to achieve and how are we delivering that right now, and then we can sometimes find quite simple solutions. So, apologies for the intensity of this picture. It's a little bit like you gave an octopus a paintbrush. But what it's trying to show you is the red spots are unreacted cement and different stages of hydration. Don't worry too much about the detail. Just nicked this picture from a lecture on concrete. What I want to illustrate is that in a typical high quality concrete mix, what do we have? We have low water cement ratio. So we have very little water there. The consequence of that is not all the cement actually hydrates. And it depends on the age we're looking at, but up to 50% of the cement may not actually hydrate. So what are we putting it in there for? So yes, we need cement to bind everything together, but we're actually putting something that's a very high carbon material in, and it's just filling up space. And I suspect that's why some of these less reactive replacements like limestone fines work quite well. They're doing that task of filling the space, and we're just coating them with the things. So we need to look in detail about what are we trying to achieve with the concrete we're doing, rather than looking at sort of the more exotic, new materials that are unproven. Let's see if we can optimize even just the packing density. That's what gives us actually strong concrete. Here's a few things that we've actually done. We've spent a lot of time talking to suppliers. That's been really fruitful. For example, I mentioned the grout as being a hotspot that surprised us. And we realized that what we had in our specification was probably going to cut out some of the new grouts that we see that have much lower carbon. So we've had to look at ourselves and see, what are we doing actually to enable this? Rather than just turn around and expect the industry to deliver, we have to recognize that quite often clients are tying the hands of contractors or designers with some of their requirements. So that dialogue's been really helpful. There is a lot of these fundamental assumptions. If you think about durability, quite typical to look at a line and say, okay, what's the worst spot? It's here. Okay, we apply the same approach all the way through. And that's just lazy engineering. Yes, if we have different concretes in different places, that's going to be more complicated to manage during construction, but there's a sweet spot in between where we can try and optimize, and we can give the freedom to have lower carbon mixes. Then we move into cement replacement, all very standard. You're very familiar with that. I've picked out GGBS here because it touches on another common problem we face in this area of carbon management. And that's sort of the engineering culture you have in a place. So we don't have any steel industry in Denmark. So we don't have GGBS of our own, and therefore it's not been traditionally used in concrete. Now, we've used it in the segments, for example, on the Southern extension, because they were made in Germany. But it's so, let's say, exotic that I was on site last month talking to an engineer and he said, man, you know, we could have done so much more with the concrete if only we'd been allowed to use GGBS. But that person didn't realize that the national annex for Denmark's EN 206 does allow GGBS. But people are so used to using a certain limited palette that they're not aware of what can be done. And we need sort of, events like this where we're trying to share knowledge to open our eyes to what is standard, well practiced in many countries. I mean, GGBS has been it's such a normal thing here, but in other places it's seen as something quite exotic, therefore quite uncertain. We need to try and improve that sort of interchange of knowledge. What I can offer in return is that we have calcined clay as a low carbon alternative, and that is on the market right now. We can go and order concrete mixes which have cement that's based on a calcined clay. And I know Portland cement is a calcined clay, but there are different types of calcined clay. The problem with something like fly ash and GGBS, of course, is there is a limited supply of that waste material. It's great as a waste material, but everybody is reaching for it. And if we think longer term, we need to have more sustainable solutions. Clay is a massively abundant material. If you calcine certain types of clay, you're using less energy, and you can see the embodied carbon is about 500 kilos per ton versus a typical Portland cement, which would be closer to 900. It's not an answer for everything. Like all materials, it has strengths, it has weaknesses, but for a lot of standard concrete, a calcined clay type mix is an interesting step forward for the future. The final one I pick out from this list is we're going to have 56 days, or we are at the moment using 56 days as the evaluation age. I'm sure you're all used to, going to university, you open up the textbook and it says at 28 days, it must be this and this. There is nothing magic about 28 days. It's just, it's a convention. It's convenient. It's sort of like a month. It's 4 working weeks. It's just something we have used. At times it can be, it's suitable to be judging everything on 28 days because that affects what you might decide to do or not to do. But in many occasions, we're not actually going to apply the loads to a material until it is more than 56 days old. And we can cope with dealing with any adverse information we get about the performance of that material, or even you can guess from a 7-day strength what's going to happen at 56 days. So the 56 days is a nice, again, simple thing you can just write in. What it typically means for a concrete mix is you could drop a strength grade. And of course, that saves you carbon. If you wrap all of that up, when we look at the design for the M5, we're looking at, our working assumption is that the structural concrete will have an embodied carbon of around 160 kilos per cubic meter. So that's where that all sort of combines to come together. So now I'll turn to the sharp end of the business, which is when we actually try and build this. And the things we need to consider there are how we monitor the actual carbon footprint. Are we achieving what we thought we would? The requirements, of course, you're going to have hard and soft requirements. Hard requirements is, it must be this strength at 56 days. Soft ones, we can work, we would like to work together to explore, blah, blah, blah. You have to accept that soft requirements will not really deliver anything. You shouldn't expect it to deliver anything. If it does, great, but I'm really not a fan of putting in a soft requirement. If you know there's something you want, write it as a requirement. These sort of things just create an illusion of making progress, but ultimately rarely deliver something good. I'll talk a little bit more in detail about each of these. We have the evaluation process, of course, and we've got different variants in the contract in terms of like priced options and, of course, penalties and bonuses to Ash. If you're interested, the little graphic there is from our current reference design. That's the heating ventilation system. So this shows you how much information we have even at this stage in the BIM model, and we should be making use of that. The green dots show you what we are doing at the moment on contracts. We are measuring the carbon footprint. We do have requirements, for example, on emission-free equipment, supplying EPDs, the competence of people handling the sustainability issues, and to a degree, it appears in tender evaluation. When I talk to people who are working with monitoring carbon, quite often it appears as like a parallel process. So at the end of the month, somebody's running around trying to gather information. I should say, if you're lucky, it's at the end of the month. Sometimes it's at the end of the project. You run around, you gather information, there's lots of bits of paper, tapping into a spreadsheet. That inevitably produces really poor quality data and is a pain in the neck to do. What we'd like to do is try and put the carbon monitoring, attach it to an existing process. So the carbon estimate, as I mentioned, it has the same structure, same work breakdown structure as the cost estimate. And it's like a bill of quantities. A long list of objects, an emissions factor associated with them, multiply it, you have the answer. When we monitor progress, we're going out, we're looking down that list of objects and saying, well, how much of the stage is done? Well, that's 100% done. And how much of the walls? That's 50%. So you know how much has gone, and that is used, for example, for interim payments to see. So we can take that same information, that percentage complete. We have an as-built, we will have an as-built BIM model, so we know the objects in there. All we need then are the actual emissions factors associated with the concrete that was poured, the materials we used, and that will give us for the objects, effectively we'll get this sort of this spend of carbon. So we'll have an S-curve, just like we have with cost, and we'll be able to see month by month, are we on budget or are we overshooting? That's fine for objects. You still have activities, but even that, when you think about it, activities, it's hard to associate them to the individual object, but on a let's say a site level, you've got an electric meter, you know how much fuel you've delivered, whether it's diesel or biodiesel. Those are only 3 things we need to record on a monthly basis. And we can put that together. And I think that is the way we take information we're generally gathering anyway in a process that we have. We'll get a more robust measurement as we go along. I've mentioned in passing environmental product declarations. In case you don't know, an EPD is a third-party certified document for something like a cube of concrete, which will tell you a range of different sustainability indicators, how good or bad it is in each of those categories. One of them is the global warming potential. So that's what's typically known as the A1 to 3. That's the manufacturing of, let's say, that piece of concrete. And then you also have sometimes the transport, if you know exactly where the site is in relation to the production. So that gives you it should give you a reliable source of the information. You've got a document that backs up what is the carbon embodied in this object that you have delivered. Very standard in Scandinavia. We required on our current jobs for structural steel, reinforcing steel, and the concretes that's poured. There are a couple of issues to raise with materials. First one is material miles. If you're eating strawberries today, they're not growing in the garden in the UK or Denmark at the moment. They've been imported from somewhere, and we have that choice. When we go into the supermarket, there's that concept of food miles. You can choose whether you want to have something that's been imported, traveled halfway around the world. We need to start thinking about the same for materials. Does it make sense to have steel that's come halfway around the world? That has a carbon footprint. The other issue is, yes, you can have an EPD, but you need to look at them critically. Just because it's green does not mean it's good. Even the contract form has an influence on this. We use all types of those forms. Generally, it's D&B, but we've just started on this M4 extension project, which is an early contractor involvement. I think early contractor involvement is great. As a client, it allows us to have much more influence on the design as it develops into the detailed design. So I'm very optimistic about how that will develop. And of course, this is very standard for you in the UK. All the work that's been done with new engineering contracts has paved the way globally for this type of this better form of contractual relationship. And I should give a plug for X29, I think is the clause in NCE, which addresses sustainability, gives you a nice little template you can use to put in, for example, targets and so on. But even within those contracts, you can find subtle things that will help the carbon management. So previously, we would have the first stage concrete, which is the yellow element there, part of the civil works, and then the rest of the track is done by the TS contract. Trouble is that the top surface of that yellow element is quite critical. And you sort of basically end up in a situation where you have to cast that because there's a tolerance. You can't just put it in any old shape because you're interfacing with another contractor. What we've decided to do is put all of the permanent way into the civil works contract. That means that the first stage concrete, the yellow there, could be precast and dropped in, and whatever the tolerance is can be taken out when you cast the permanent way, the second stage concrete running through. So there are areas and interfaces that you can look at. Coming towards the end, I've talked about emissions-free equipment. As you can see, right now on site, we are using emission-free equipment. Anything under 10 tons is electric. Everything above that is using biodiesel. It's what's called HVO 100. It means that it has to be a genuine waste product. It is a problematic area, biodiesel. How do you really know that this is not something that's been grown as a crop? So with all the problems of the change of land use that may be coming from those emissions, and then turned into biodiesel. So we would like to push this further and have more emission-free equipment, but it's an area where it's quite hard to make a hard requirement. And I think that maybe this is an area for, let's say, a price alternative, where we ask contractors to say, what would be the extra premium if you had X number of hours with emission-free equipment or something like that. The alternative you sometimes see, and I should be prefacing these comments by saying this is very much work in progress. So we have not finalized what goes in terms of the requirements quite yet. An alternative way of doing that, which is used in some places in Scandinavia, is the client will pay for every extra kilowatt hour that's used for electrical equipment. So there's an incentive. There are options there to be used. I've talked about material caps. This is quite a good way to sort of suppress the carbon and avoid it sort of escalating during construction when the pressure's on to deliver work and people say, I have to pour now. The only thing I can pour with is this dirty concrete. Do you want it? Yes or no? That's a very difficult situation to be in. But we are at the moment using caps for concrete and the other materials I mentioned. We need to tighten them. The level we have for concrete at the moment at 350 is way too high, but we need to progressively work with what's available in the market and tighten that. And you can see that other clients are using a similar system, and that's sort of developing as quite a useful tool. Overall, the procurement system does need to be reformed. So increasingly, you're seeing that the carbon is appearing as an evaluation criteria. It has to. We have to remember this is a cost-optimized industry at the end of the day. We evaluate contracts quite often on a mixture of quality and price, but to be honest, when you've pre-qualified, you've got 3, 4 really good contractors, they all generally score quite high on quality. And the danger is you end up back looking at basically a price race. So we need to think about ways to evaluate tenders that will mitigate against that and make the greener options decisive in that. So the two sort of models I've seen at the moment, the first one is you take the offered price and depending on how much carbon has been saved, there's a modification in a sort of an evaluation sense that you can reduce that price by X million according to how good the bid is in terms of the carbon footprint. So the offered price is what will be paid at the end, but for evaluation, the price reduces. And that is one way to sort of recognize also the additional costs that the contractor would be spending to achieve those savings. Really tricky to choose the price to put on carbon at that point. So that's one model. An alternative is you just simply score the carbon footprint. You ask for a carbon footprint for the tender design. So this is the price and this is the carbon you will get associated with that design, and then you score them relative to that. So as I say, we're still working on what that should look like. Similarly for penalties and bonuses, as I said, at the beginning of a project, you can be saving money as well as saving carbon. But as you get through to the construction stage, when you're replacing materials, you're using different types of equipment, there's a cost impact there. And we need to recognize that and reward that in some form of bonus. You can see quite a spread between different clients. I think I've got the numbers right, but I'm happy to be corrected. There's also quite a spread in terms of the penalties. Personally, I believe there should be a penalty if somebody is committed to do something. If that's not delivered, there has to be a consequence to that. But it's a difficult area. Some clients feel the penalty should be much higher than the bonus to make that sort of make it clear that this is what they want to happen. They want positive progress rather than negative. But it's again an area that's under discussion at the moment. An alternative is to have sort of like an innovation fund and say, okay, you come along with your ideas and I've got a pot of money. If it's a good idea, you tell me how much extra it costs, I pay you. The risk, I think, from a client point of view there is, are we actually paying twice for the same thing? Has something been included in the bid and then it's repackaged and said, well, actually, we suddenly discovered we could do this and can you pay us extra for that? So the innovation fund can be a little bit problematic as an option. Finally, I think when I look more generally, I have to say carbon is only one fraction of the sustainability puzzle. We are trying to look at other issues such as material use, particularly certain rare materials, scarce materials. We need to look at biodiversity. Admittedly, on-site biodiversity is actually more for us as human beings. It makes us feel good. If you imagine walking up to a station like that, you feel good. Has it really changed the biodiversity in the world? No. It hasn't, but it is actually good for, let's say, our mental health to be in spaces like that. It's actually good quite financially for us because when you study how people behave, if a station is a welcoming place, then people will come and use it. And we have to think about, we do think quite a lot about what does our station look like at different times of the day. A space that is very welcoming in the daytime can be quite different character at night. there's other areas in this general topic that we're trying to explore and look into. There are certain co-benefits that are really worth exploring when we look at, for example, emission-free equipment. You've got less particulate emissions from that. It's much quieter, as well as the carbon saving. And those factors need to be considered. Within the ITA Sustainability Group, we're looking at this puzzle about how do we evaluate projects and how do the full benefits, how are they incorporated when people make decisions about whether we should or should not progress projects. I'll skip over the detail of the challenges, but I really want to just highlight that we don't have all the answers, and we're very, very open to talking with people and gathering from you your experiences about how do we cope with, for example, the fact that we set requirements for things that may be changing considerably over the period of the project. How do we safeguard space for innovation with things we're not entirely sure about? Systems is a very good example where it's quite difficult to write in hard requirements when technology is changing so fast. So we're very open to having a discussion about how we can improve what we're doing. So in conclusion, as I said, sustainability is much broader than this, but this is the subject that we're working with most directly at the moment. I think I can easily see a situation quite soon when governments will have carbon budgets and be saying to their organizations, their client organizations, you have a financial budget and you have a carbon budget. And if your projects do not fit into both, they will not be built. So this comes back to us. What can we do? If we're building something new, we inevitably have a high carbon footprint in the embodied material that we build, but we're building it for a good reason. We need to make sure that those benefits are articulated well enough, and also we do enough on the other side to reduce that footprint that we can do. I still don't understand why I can't get the order to work. Innovation is a key part of that in terms of how we reduce this footprint by the sort of the active carbon management. If I look at M5 right now, we're about 40% saved compared to that baseline of what we've just opened with current emissions factors. I'm optimistic we can get through to the 50% and beyond that, but that only works by having this active management approach. We definitely need to reform procurement. And in terms of the monitoring, we're looking for that streamlined way. How can we measure something on a month-by-month basis so we can steer projects and do that in a way that is smooth and it creates a minimum burden as we do that. So I hope that's been informative in some way. Thank you very much.
Thank you, John and Alan. Personally, I found that fascinating, and carbon management is, in my head, has been a lot about materials, and you've really opened it up that you have to consider the whole life. And the phrase you said, sometimes you have to invest carbon to save carbon is struck home with me as well. And I've never visited Copenhagen, but I feel like I have now. Thanks. Okay, we'll take some questions then, please. And can you just, yeah.
Me?
Where are we?
I was given a microphone. Yeah, thanks for a very interesting presentation, John and Alan. I was interested, Alan, with your discussions about refining design. One thing you did, you went on about 28 day and 56 day strengths, etc. One thing you didn't touch upon is this partial safety factor, material safety factor for concrete of 1.5 that we've been using since Aspen invented cement. Now, when I first went into the design as a design engineer, graduate design engineer 50 years ago, the partial safety factor of concrete was 1.5. We're still using it, even though we have much better quality control. I mean, in the old days, it used to be 1 shovel of cement, 2 shovels of sand, and 4 shovels of stone. We're far more sophisticated now. And 15 years ago, I co-authored an ICE report pointing out all of this about the ridiculously high partial safety factor on concrete. So there's no.
Yeah, and I agree. This is where you need to go back, as I say, to the fundamentals and question. So yes, we have this creative tension between the desire to be conservative, to have longevity in the structures, to give people that confidence that it's safe to drive across bridges, sit in trains through tunnels, and that's always going to be a tricky one to balance, because at the same time, within well-established, well-regulated engineering environments, you see structures fail. So you have to balance that. But I'm sure that you're right. There is scope to improve that, and we've seen it happen with steel, for example. Steel, when I started my career, which is it's quite a long time, not as long as your career, but that was 1.15, and now it's 1.05.
Yeah, and a complete underground structure has a total safety factor of about 3+.
I would totally agree with you. So, as John explained, my background is a designer, and quite often I've looked at designs and thought, my God, there is a lot of concrete in here. There's a lot of steel. We've all seen that, and we've all been in situations as designers where the environment has pushed us in a certain direction, but we have a responsibility to sharpen our pencils, or whatever the digital equivalent is, and come up with better designs. There are too many occasions where we're not serving either society well by producing these overweight structures, or our clients. And it may require people to stand up and say, no, I'm sorry, client. The reason I think it can be done like this is for these reasons, and this is why it actually makes sense. So yeah, I totally agree with you. Better design is a key to this, as John noted. It's not just some magic material at the end. Fundamentally, good, elegant, optimized design. That's what we really need.
Just a word on that as well. There's a lot of people to convince about any of these big changes. Just say that we buy into it. We've also got our consultants that also have to be on board with these changes. You've then got the contractor, and then you've got their designer, you've got the Cat 3 checker, you've got the safety process. You've got quite a lot of different bodies to convince that this is the right thing to do. And so I'm not saying I disagree with you at all, but with all the innovations we've got, it isn't just about convincing us. Firstly, we convince ourselves if it's a good idea, but we've got so many other parties to convince. It's hard work, which is our biggest benefit by having an innovation process that's been going on for 5 years. And that isn't something as complicated as codes and standards. We've got lots of people to convince that it's a good idea. And more than half the work is to convince everybody involved. It's quite tough, but we're getting there. Say 25% hit rate on the innovations. I'm quite proud of that, but it's meant a lot of talking to people to convince everybody involved along the food chain that it's a good idea. And the ones that we're getting in it are the ones that everybody so far says, yeah, that's a good idea. We can go further, but we are touching upon some of the codes. We're looking at minimum steel that's going into our concrete. We're looking at either crack widths the right size. How can we adjust this to suit what we really need? Because sometimes, especially with things like crack widths, you put so much steel in there that you end up causing voids and honeycombing and all sorts of things. So let's be sensible about this. What do we really need? Go back to the functional requirements and not over-design it. Get it just right.
Thank you very much indeed for this talk, John and Alan. I've got a question for Alan. In the slide that you used, Alan, for illustrating the advantages of a shallower station, your slide had a comparison between a deep station and a shallow station, and the deep station accommodated, as far as I could see, about twice as much stuff or twice as much space as the shallow station, and it's fairly obvious that if you build half the amount of space, you'd expect to build it cheaper and with less carbon. So I wonder whether your carbon calculation included the relocation of all the kit that would otherwise not have been in the station. Because in my experience, people living around the outside of metro stations would largely want everything put underground that could possibly be put underground, which is why we have ticket halls underground and substations underground and so on. So did your carbon calculation allow for the relocation of the kit that you couldn't otherwise accommodate?
Yeah, no, it's a very fair point. Some of the stations have been very well optimized inside in terms of the rooms. So we do actually see that if we push it too shallow, the things spill out the other side, and we end up with shallower boxes sort of extending either side, as you say, to accommodate the things that need to be on the ground. But with some of the deeper stations, there's actually quite a lot of fresh air. So what you're doing is you're concertining something and you're losing air. So this is why you can see sort of a big change in volume, but you're not seeing quite so much change in, let's say, saving carbon, because what you've lost is air. And that's why you're also able to do that without spilling, squeezing other M&E rooms or equipment rooms into different places and having to spend carbon to put them into a shallow basin side by side. But yeah, it takes a bit of thinking, and this is where the BIM models become very, very useful, because you can on a very coarse level say, well, I need X amount of space here, and then that is going to move, and you get that instant sort of feel for what's going to happen.
Okay, there's a question down here.
Hi, on one of your slides you mentioned.
Sorry,
that
can
the-
you just give your name as well and affiliation? I forgot to say that earlier.
Yeah, sure. My name is Adrian Spencer. I'm a IC member. I was curious, on one of your slides you mentioned that the annulus grout is a lot more carbon intensive than the concrete lining of the tunnel. And I was curious as to why that is, what makes it so.
Because it's full of cement. The baseline is what we used in the last project, and the last project it was fairly cement intensive grout, and that's the carbon footprint. Bear in mind that was a grout that fitted the spec that was written about 7 or 8 years ago. We know full well that modern grouts are much better, and we've had to learn about how on earth do we make sure that we ask for the right thing. And we know we can do better than last time. We know it, but we had to make sure the spec was written to suit the modern grouts that have the less cement that do the job.
But it's also worth bearing in mind that the thickness. So I might be struggling, John can correct me, but I think it's 150 mil is the annulus that we have. They're 5.5 meter OD tunnels, but we have quite tight curves. So we've gone into, talked to TBM manufacturers and said, seriously, do we need so much of an annulus around this? But they're saying, well, if you're going to go around those curves, you'll need to have a machine of this shape. So it's partly the combination of the intensity of cement compared to a concrete, especially when you've got a lining where you're using a 7.3B type mix, and the thickness that, if we can find a way to reduce the thickness, of course, that would also be a great step forward.
From memory, the carbon footprint of the grout for the M4 was 305 kilos per cubic meter, and I will eat my hat if we can't do better than that. Significantly better than that. The question is, how much are we willing to pay for that? We think that we can go quite a bit lower without without any extra cost. And the real challenge is of where do we draw the line? Some suppliers have told me we can cut that into 3. We can do a third of that. It'll cost you. So we've got to behave ourselves because we don't want to be blowing the budget on quite big item. So the real game is to how much are we willing to pay for that carbon saving. If we can pay nothing for it, great. If we're paying a little bit, we might be open to that, but this is the game about how much is it going to cost us. But we know we can go lower than 305, definitely. In fact, I reckon we can go, well, I don't know. I'm not going to, don't put on the spot on the number, but I'd say that easily a third of that can come off. 200 sounds about right, but are we going to pay for that? So what we put in the contract, we might be putting on a requirement about we want a grout that hits this lumber. Do we pick 280? Do we pick 250, 220? This is a difficult question, but we'll be putting something in there, I think, because we definitely want lower than what we've got before, which was a bit lazy. Because there was no number last time. We just said we want some grout that fills the hole. Great. So we'll push it a bit.
Okay, thank you.
Okay.
So Duncan Nicholson, what are you doing on long-term structural health performance and monitoring so that you as a client monitor your structures? You mentioned monitoring. What are you doing to feed that back into performance and material?
It's a very good question. We did install, as you may know, some sensors monitoring on both the M1, M2 and the M3, the city ring-in sections. It's incredibly valuable information to get hold of, to have that, even if we only have sort of a 20-year sort of track record to look back on. As you're sort of alluding, it's really useful to understand where is the margin. You know, Charlie talked about that extra safety margin. What can you learn from either the loading on linings or the behavior in terms of, let's say, chloride penetration or something like that. Unfortunately, it's been a real struggle to get the information out of those centers. So, and that goes back to something that those of us who've worked with instrumentation have known. You need to be really careful about what you, how you specify the type of instrumentation you put in. You need to think about redundancy, about the fact that you will inevitably lose some of these. And you know, simple things are inevitably better than more complex ones. So sadly, we haven't really been able to pull that sort of information out. But it's an area that we definitely need to do better in. If I can plug something from the ITA Working Group 12, we have a project running at the moment where we're trying to get information on what's the title? Something like in performance behavior of spray concrete permanent linings, where we've gone back to projects all around the world and tried to learn from clients where the problems are arising and where things are going well, and try and correlate that to give guidance, at least in that area. But sadly, we ourselves have not done terribly well on this one.
Okay, I've got one online. This is from Ashish Thakkar. What will be the substitutes admixtures for the pure cement grout to lower the carbon?
That's a great question. I've been trying to work out what it is, but none of the suppliers will tell me. Top secret, special magic formula. If only we knew. And that is a big problem, because we will want to know what it is. And we've been discussing, well, will they go and give us an EPD for it? Will they tell us what's in it? Because you do have to get it approved by the, you know, the local authorities will want to know what we're pumping into the ground to make sure we're not poisoning the ground. But we do not get a straight answer. We know that it's got low carbon, but what is it? We don't know. So, and you know what? We don't need to know just yet, but we will need to know before we put it in the ground. So maybe if the contractor can promise something, we will be asking for the EPD. So if there's any suppliers out there that can give me an EPD and tell me exactly what's in it, we'd love to see it so we can get it pre-approved. But no one's given me anything yet, and we've been speaking to everybody. So good question. Not a very good answer.
More questions? Yeah, in the back.
Good evening.
You got your name,
Roy
please?
Slocum.
Good.
You mentioned several times about using low emission equipment. Do you also consider the supply of the equipment? Thinking in terms from the tunneling equipment, the one contribution the tunneling machine manufacturer can make to lowering the carbon is the incorporation of remanufactured components. Is that something you encourage in your specifications?
I think it will be.
Yeah, so the short answer is so we're still working on exactly how we formulate it, but my preference generally will be to looking at incentivizing the overall reduction. So I've explained that we will have caps on certain materials, annulus grout, concrete, steel, to avoid the actual performance going the other direction. About, you know, we end up with dirtier sort of materials than we'd expected. But otherwise, I think our approach would be generally to leave it up to the contractors to find what is the best way in their mind, their experience, to deliver the overall savings. So in that sense, we're agnostic. We don't mind where the saving is made, as long as the savings are made. And you're right, a TBM is a massive object with a lot of steel. If you're buying a brand new TBM and everything's brand new, then of course there's a considerable embodied carbon in that. But yeah, I mean, we've all worked on machines where they've been gone round and round the world on multiple projects. So it's an area where actually the industry has done very well in terms of circularity. The fact that we keep using these machines is going well, and I'm sure we can do more.
But it's somewhere that you need to encourage actually in your specifications. And can I comment on the question there? You were talking about the low carbon grout. When we had to rebuild a section of the Northern Line just south of Old Street, because of the acid content in the ground, there was a requirement in the specification to come up with a very, very low carbon grout. Now, that was just basically sand grout, very low cement content, sun bentonite. So none of the fancy additives you're talking about now, or none of the fancy additives that seem to be common practice on sites these days.
That's a fair question, and I think we've looked at things. Does it need to be cementitious at all? Could it just be pea gravel coming blasting sand? But it is about the geotechnics. What is the geotechnical conditions, and we've got to do something that does the job, and that's where we're going to be going with this. So no, we're well aware that there are other solutions out there.
Okay, question at the back, yep.
Hi, yeah, Robbie from Joseph Gallagher. Just a first one, I'd just like to know what you think the impact of the CBAM regs coming in, and if there's any opportunity there for the UK market, saying they're a year behind in terms of introducing the regs in 27.
So, to be honest, I'm not sure what's happening with CBAM. So CBAM was due to appear at the beginning of either next year, I think was the first. So CBAM is was it cross border adjustment mechanism, which is an EU let's say tariff to sort of compensate if materials being produced in a country which is very carbon intensive. When it's imported, then you'd have to pay some penalty for that. So obviously, if you could produce low carbon materials, that's fine. So the idea was to incentivize low carbon supply rather than keep importing high carbon materials and just offshore our emissions, basically. So I'm not quite sure. I think that somehow it's already been postponed a little bit as part of the general watering down of efforts on climate change. And I have to confess, I don't know what the situation is in relation to UK, but that should be, in my view, a positive step forward. If we are trying to level the playing field, because I think the big issue that I'm sure has been discussed a lot in the UK in relation to steel is the question about dumping of steel. And yeah, it's cheap and dirty. It's come from somewhere else. Incredibly hard to maintain a steel industry when you're facing that sort of unregulated, completely open market. And you know, I think there is a very strong argument for imposing that sort of restriction, because otherwise we're just shooting ourselves in the foot, and we're not actually achieving. So I'm not sure if I've answered the question properly, but that's my personal view on it.
Okay, we've got one online here. This is from Vivek Tiwari. Thanks for a brilliant presentation. How is future expansion considered with respect to carbon management?
Future expansion in the sense of when we're building the new lines, I think that's a good question, and you have to think about where your baseline is. Baselines tend to be sort of associated with a date, and the further you move from that date, the more problematic can become. So I think that we would, as we sort of move beyond into other projects, we might well be then revising what our target is and saying that for project X or Y, we're going to set the baseline here, and therefore the target will be whatever it is in line typically with sort of national targets. So I'm not sure if I'm answering the question, but that's one aspect. If we're thinking about future-proofing in relation, let's say, to requirements, that's definitely very difficult to do where you have a long-running contract. We're about to renew the contract for operating the metro, and there's the scope within the operation to be reducing, for example, the energy we're using. But predicting what it is, what's going to be available in 10 or 20 years' time is quite difficult to write into a contract. So apologies if I haven't answered that properly, but that's what I can offer.
We've got one here as well. Greetings from Copenhagen. Wonderful presentation, Alan and John. And that's from Vidi Rathor. Okay, maybe time for one more question. One or two. Yeah.
I know. Yeah, I've got the microphone. It's Chris Dewlake. Both John and Alan, you both worked in the UK historically, so you've got a good track record of delivering here. Do you think that working in Denmark has enabled the sort of more minimalistic approach to what they do, enabled you to manage carbon down and put these measures in place? And is there anything that you think that we could learn from some of the things that you're doing that we're currently not doing?
That's a good question. Just give me a minute. I think having a very proactive client. I mean, I haven't always been working with Metroselskabet. I've been there for 18 months. The client has always been fairly pushing to try to do something a bit different. We've had innovation from the first Metro when they started using driverless trains. They've been trying to do things a little bit different. They're not scared of it. And to do things a bit different, you've got to be brave. And the Danes aren't scared. They've got to do things correct. They've got to de-risk it and do it the right way. But we are also quite a small country, and there's the routes to go and get things approved. Maybe it's a bit easier in Denmark. Maybe the sort of the attitude of the Danes is such that things may be a little bit more easy to change into a different way, and they're very accepting of that. But it's just so there's some Danes in the room. It's a small country, and the Metro hasn't been around for ever and ever and ever. And I think they do accept these ideas quite openly. The fact that our new chairman, who started earlier in the year, that he's got the wind beneath his wings, and he's pushing us to go and not take risks, but take risks at the right time, the right place, and understand what we're doing. And we do have to report on making sure we know what we're doing. But it does feel a bit easier than in the UK. But maybe it's the size of country. I don't know. Alan?
I think it's an interesting question. And I would say there's a different balance in my experience. I think actually, so everything John said is very true about Metroselskabet and the situation we're working for, but I'm not sure that's generally representative. We're in a sort of strange position where it's very positive as an environment to work in terms of the governmental push, the public opinion. There is a very strong support for doing things that deal with climate change. So that's great. That gives you a very strong sort of background. But I think what I've gained from sort of learning my trade here in the UK is a breadth of approach to solving problems. So I very much remember working on projects here where we were not afraid to say, well, there isn't a particular standard for this, but there's a guideline here, and we've looked at fibers is a classic example. Working on the baggage tunnel in whatever 94, there was no British standard for fiber reinforced concrete. But there was a willingness to say, okay, if you give me a good engineering argument and you've got some calculations back it up, this is something we'll accept. And I see that repeatedly in UK, and you see quite innovative engineering. There's a willingness to have design and build in a genuine sense where you can change things, where you can come along with it as a contractor and say, no, I'm going to ditch that shaft and I'm going to put this here and put that there. And when I talk to people who've worked, let's say in Central Europe, take Germany example, design and build in Germany means I've designed it, you build it. There is very little room for maneuver, and I'm sure you've talked to colleagues here who enjoy working in the UK because you have that freedom, and the same you see the same also going around other parts of the world where they're very rigid. This is our standard. You must comply with this. Don't come with innovation. So I think it is a bit mixed. That is the strength of the engineering culture we have in Britain. That willingness to explore and do those things, and that's something that's definitely other countries could benefit from. But having that, it's certainly easier to have that leadership. That if politicians have agreed that this is something that's worth doing and we will support it. And I was at a debate this morning about it's more like related to the financial industry and why we haven't really achieved net zero. Why is progress so slow? And the comment was made about electric vehicles. We can't. Nobody wants them. But the situation is exactly the same in Denmark. It's come from a government target. We should change this. I think the difference between Denmark and the UK is the government is much more supportive for the general infrastructure. The other aspects, it's not just a simple, this is a target, somehow you have to find your way to that. There's more thought put into creating the supporting measures or actual physical infrastructure that enable that change. But you do need to have that leadership at the top. Otherwise, we work in the environment that's shaped by that politics.
Okay. One more last question.
Hi, Ian Watkins from McDonald. You talked about precast inert concrete. Something you were looking at a few years ago was using a floating slab track system and a non-bounding fill beneath it. Precast in a tunnel your size is quite difficult to maintain the invert drain, how that works. How far did you get on the non-bound solution? And is that something you would look to promote as part of M5?
It's a very good question. We have certainly discussed that option about what is the first stage doing. It just has to stay there. But all it has to do as a nice solid basis for the whatever you put on top. And this is basically why we've changed the interface between the two contracts. So I think we're open to people coming to us and saying, actually, what we could do is this. I think as we sort of talked through it, it wasn't clear to us if you boil it down to the logistics, which is going to be easier, dropping in precast elements or laying in something, compacting it, and I think that is a question that as a client, we're never going to be able to answer. That's very much a question that we want to hand on to contractors and say, okay, what do you think is going to be the best way to do this? And then we were trying to just free that up by the way we arrange those interfaces and say, the ultimate performance is the track has to be here. This is the running speed. Over to you.
When we discussed the use of a precast track slab, when we discussed it with our construction guys, they liked the idea, not because of the cost or the carbon or the program savings, which there's a bit of both in that somewhere. They said it's just nicer for health and safety. If it's precast, you can walk on it without turning your ankle. And they really liked it because pouring wet concrete in a tunnel is horrible. Anybody that's done it, it's just unpleasant and it's a health and safety nightmare. So if we can get rid of that, if we have a precast solution, it's going to win because of the health and safety, which is a really nice reason to do it. There was a project, I'm going to get the project wrong, I think it's somewhere in France, where they used a precast slab for temporary works. So it's easier to walk down the tunnel because they didn't want to turn ankles and fall over. And then they had to go to their client saying, do you mind if we keep it in as the permanent works? And because it isn't particularly high strength product, it was actually, I think it's going to be okay for permanent case. But yeah, we're open to that, but it doesn't have to be for those typical things of cost and program. Health and safety is a great reason to put in. But yeah, no, we will be leaving it open, I think. No, make any promises, but yeah, it's a bit difficult to have first and second stage being precast for tolerances. One of them might have to be wet, but we're now putting them in the same contract, which means the contractor can choose which one's precast and which one isn't. And if they can do both, great. But we kind of hope that they're not both. I'd love it if they weren't, because it's just nicer for us clients to go on a site visit down a nice clean tunnel that's got a nice flat plate to go and walk on.
Okay, well, thank you very much. Fascinating. Just a couple of announcements before we retire to sausage and chips. Talking of which, they are sponsored tonight, food and drinks by Rambo. Thank you very much. Just a bit of sad news. Those of you that knew Anna Simic recently passed away. She was a technical director for AECOM and built up a very close working relationship with a lot of contractors as well. So, okay, next Tuesday, digging for net zero, how past 2080 applies to tunneling and geotechnical engineering. So very much aligned with what we've been talking about this evening. So Dr. Keith Bowers and Dr. Neil Phillips will be talking there. That's next Tuesday here. And then next Thursday is the Winter Social. That's the Young Tunnellers in association with the British Geological Association. That's between 6 p.m. and 10 p.m. Sorry, that's at the Drafts in Waterloo. And there's a QR code there. There's the TBM Disc Cutter Roller Trophy up for grabs in the BTSYM Annual Pub Quiz, which has been provided by Heron Connect. What we got there? So things out of sync. So another BTSYM social on the 3rd of December. at 11 o'clock, World Tunnel Day, online mini conference. And again, you've got a QR code there. And then our December meeting, 11th of December, slipform tunneling, revolutionizing tunnel construction. Should be fascinating. And that's Professor Colin Eddy and Dr. Henry Paridou. So they'll be talking about that in December. And our January meeting, design and construction of propless openings. So opening sets on HS2, lots S1 and S2. So that's Thursday, the 15th of January. Okay, so the BTS conference, biannual conference, 6th and 7th of October. That's going to be held just around the corner at the Queen Elizabeth Centre. There'll be an early bird rate to get your tickets in. We really want to encourage as many people as possible to come along, suppliers, great networking opportunity. And it's good value compared to some of the other conferences. If you get in early, you'll get your tickets cheaper. January coming out? Yeah, January. So look out for that. And that's going to be in October. Okay, we're almost there. Continue joining the BTS. So if you're not a member, it's very good value, £93, I think, at the moment. Young members can also join the Young Members BTS. And then Christmas coming up, lovely present is the BTS at 50 book. Those of you who haven't got it. They're available. You can go and pick them up at LBA offices. We've even got books now in the Brunel Museum in their shop. So, and you've got online QR code, and we've also got on the website. And we continue to go around universities and schools promoting this, donating books and increasing the profile of tunnelling and the society.